Good morning, students. This is Junita Mukherjee once again in SS Public Skill, giving you the notes of the chapter Thermal Properties of Matter. In this particular chapter, now we will learn about the latent heat. So, latent heat is given by the volume Q is equals to M into L, where L equal to Q upon M itself, where Q is the quantity of the heat, and M is the mass and L is the latent heat itself, and its SI unit is joule per kilogram. So in this particular temperature versus the heat of water at 1 atmospheric pressure, not to scale, here we have 0 degree to 10 degree centigrade, where 0 is the solid phase of the particular ice itself, its melting point 0 degree. From 0 degree centigrade to the boiling point 100 degree centigrade, its phase change, that is, it will change into gaseous phase. In between these two limits, there is a liquid phase of water, and this thing is the solid phase of water with below 0 degree centigrade, and this is about gas phase, and it is about 22.6 into 10 power 5 joule per kg, or 540 Kelvin calorie per kg, or the melting point is given by 3.33 into 10 power 5 joule per kg, and this 80 degree kilocalorie plus 1 upon kg itself. So 80 kilocalorie, it's the value of this particular this water. So this particular phase is being given here, that is at boiling point it is abruptly changes to a particular change of gas phase and abruptly goes down, and again comes back to the same position and goes up in the form of gas itself. So temperature of the water in 1 atmospheric pressure is being measured here, shown in this particular graph itself. Now we will just learn in this section what it has been given. The section we have learned that the certain amount of the heat energy is transferred between the substance and its surrounding when it undergoes a change of state. The amount of the heat per unit mass transferred during the change of state of the substance is called the latent heat of the substance for the process. So amount of the heat per unit mass transferred during change of state of the substance is called the latent heat of the substance for the process. And if heat is added to the given quantity of the ice as minus 10 degree centigrade, the temperature of ice increases until it reaches to the melting point 0 degree centigrade. At this temperature, the addition of the more heat does not require in the temperature but cause a melting of ice or a change in its states. Once the ice gets melted, adding more heat will cause the temperature of the water to rise, and a similar situation occurs during the liquid gas change state at the boiling point. Adding more heat to the boiling water causes vaporization without increasing the temperature. The heat required during a change of state depends upon the heat of transformation and the mass of the substance undergoing a change of state. Thus, if mass of a substance undergo a change from one state to another state, and the quantity of the heat required is given by Q equals to mL, where L equal to Q upon M, where L is the latent heat and the characteristics of a substance, where SI unit of it is joule per Kelvin per kilogram. The value of the L also depends on the pressure. Its value is usually quoted at standard atmospheric pressure. The latent heat of the solid liquid state is called the latent heat of fusion, LF, and the liquid gas state changes to latent heat of vaporization, which is called the LV state itself. So it is given by the two value states, that is LV in this particular state that it changes to vaporization, and then this particular state when it changes to fission, that is melting of the substance itself. Okay, so here the liquid state changes, and thus the offered to a heat of fusion and the heat of vaporization, the plot of time temperature versus heat of the quantity of the substance is shown in figure 11.12, which is already drawn in the blackboard, and I have already shown you the melting point, boiling point, gaseous phase, liquid, and the solid phase itself. Note that when the temperature is when the heat is added or removed during a change of state, the temperature remains constant, that is the slope of the phase charge lines are not all the same, which indicates that specific heat of the various states are not equal. For the water, the latent heat of fusion and the vaporization of LF is equal to 3.33 into 10 power 5 joule per kilogram, and LV is equal to 22.6 into 10 power 5 joule per kilogram. That is 3.33 into 10 power 5 joule per kg of heat is needed to melt the 1 kg of ice at 0 degree centigrade. and 22.6 into 10 power 5 joule of water is needed to convert the 1 kg of water into steam into at 100 degrees centigrade. So steam 100 degrees centigrade carries 22.6 into 10 power 5 joule per Kelvin per kg more heat than water at 100 degrees centigrade. This is why burn from steam are usually more serious than those of boiling water. So boiling water is at a temperature of 100 degrees centigrade, whereas the gas phase is above the temperature of 100 degrees. So it is very much what you can mishap will happen with the health if a person is burned with the gaseous phase or the phase change, that is 22.6 that is above the boiling water. But if the person is hurt with by the boiling water, it will be much safer in comparison with the gaseous phase itself. So we have already discussed here, and some of the topics of this ethanol and the melting point has been given already in your book itself. And thus heat transfer. We will learn about the heat transfer, which is the next topic which we are going to start in this particular chapter. Thank you, students.